Hello, and welcome to the Science for Sleepy, where the stars hum and the night listens. Outside your window, the sky has settled into stillness. The crickets are whispering. The moon, if it's out, barely breathes. Somewhere far beyond the hush of wind and blinking lights, a star flickers, softly, slowly, like the inhale of something ancient. Tonight, we follow that light. We follow not its path through space, but its pulse, its heartbeat. If you're enjoying this quiet journey through curiosity and time, consider subscribing. There's always more to explore gently. We'd love to know your location and time zone in the comments. Let's begin. Have you ever imagined a star not as a fireball, but as a living, pulsing being? Not alive like you and I, but possessed of rhythm, of breath. A newborn star doesn't announce itself with trumpets. It forms in silence. A cloud collapses under its own weight, cold dust compressing tighter and tighter until pressure builds within, tighter still until it becomes hot enough for something new to happen. Deep in the darkness, atoms begin to fuse, and this fusion, this quiet miracle, is the first thump of a stellar heart. It isn't loud, it isn't fast, it happens slowly, invisibly. But from this hidden pulse, light begins its long journey outward. It starts deep inside, in the core, a place we will never see, but whose story we can feel every time we look up. Imagine standing inside a star if you could, not consumed, not burned, just gently floating within, like a mote inside a golden tide. Around you, particles dance. Pressure folds time inward. In the very center, the fusion of hydrogen into helium begins. That fusion isn't an explosion, it's a pressure release. A release so perfect that, rather than shattering the star, it balances it. Gravity pulls in, fusion pushes out. The two forces meet, not in violence but in rhythm, like a heartbeat, like a breath. This balance gives the star its shape, its structure, and it becomes, over time, a kind of pulse, an internal drumbeat that never echoes but always ripples. We call it hydrostatic equilibrium, but really it's just a quiet agreement between fire and weight, and in that balance, a rhythm is born. This pulse is not a constant beat like ours. It swells over centuries, even millennia, but it sets in motion everything that follows. From this soft beginning, light is made, but that light doesn't leap outward. It does not rush to escape. Instead, it takes the slowest walk in the universe. Photons born in the core scatter endlessly. They bounce from atom to atom, changed and scattered again and again, like travelers always asking for directions. A single beam of light might take thousands of years to reach the surface of the star, and during that long ascent it carries with it the signature of the star's inner rhythm, the pulse that first shaped it. You could say that every star's glow is a ghost story, a ghost of that first, quiet drumbeat, drifting out to us from a time before we were born. We don't often think of the sky as full of messages, but it is. Not in words or thoughts, but in flickers. Every tiny change in a star's brightness is a clue, a whisper from the inside, and once we learn how to listen, not with ears but with instruments and wonder, we begin to hear it, the hidden heartbeat. So tonight, as we settle into this journey, we aren't just looking at stars, we're listening. We're listening to the very first breath that glowed. We drift deeper now, into the heart itself. The star is still young, still new. It hums like something dreaming, and we listen to its silent shape light. The core grows warmer. You and I are drifting still, gently nestled inside the folds of this newly lit star. Time here is soft, slow. The particles move with intention, but never in haste. And now, in the deepest place of all, pressure has become so immense that hydrogen, the the smallest and simplest of all elements cannot help itself. It fuses, not as fire but as transformation. 4 protons become helium. A touch of mass disappears, becoming pure energy, released into the waiting dark like a sigh. That sigh is the star's first heartbeat. It is not audible, of course, not even in the way whales sing or trees creak. But it is there, unmistakable, a pattern beginning, a rhythm forming, a balance emerging between what falls inward and what pushes outward. In this moment, the star becomes real, not merely gas and mass, but a presence. You float through its interior like a snowflake through a volcano, unburned, unbothered, untouched by anything but awe. Around you, the atoms surge and shift, colliding and dancing, following the mathematics of heat and gravity and time. And yet it does not feel mechanical. It feels alive, not in the biological sense, but in the way oceans are alive, in the way gravity curls around space, and there, within that pulsing center, something beautiful happens. The energy released by fusion doesn't blast outward in fury, it stirs. It begins a slow climb outward, not in straight lines, but in zigzags, in stochastic detours. Each photon born in the core begins a journey that will take longer than human civilization has existed. We don't think of light as patient, but inside a star, patience is its only option. What happens next is not a roar, but a shaping. The internal pressure builds until it matches the inward crush of gravity. The fusion increases in strength, but the star does not grow wildly. It holds. The heartbeat stabilizes. The glow it sends outward begins to find rhythm, and so the star enters the main sequence. This is the long, stable period of a star's life, the phase our own sun now inhabits. A quiet adulthood, glowing not in ecstasy, but in steadiness. The internal rhythm is now consistent, shaped by mass, temperature, and balance. Each star's rhythm is different. Some beat rapidly, small, hot stars that burn fast and bright. Others beat slow and wide, their light stretching in deep, lazy pulses across eons. If you could line them up and listen, not with ears, but with instruments of thought, you would hear a symphony of light, not in tones, but in brightness, in timing, in variance. Some stars throb gently every few days, others take months, still others hold their pulse for years before shifting. Their heartbeats become a kind of fingerprint, a light pattern signature that tells us not only what they are, but who they are. And here's the quiet wonder. They do not know we are watching, yet their heartbeat speaks. That first thump, born in the depths of fusion, sets the tone for all that follows. It controls how the energy will climb, how the star will evolve, how it will die. The glow we see from Earth, then, is shaped by events happening not now, but thousands or millions of years ago, in a core we'll never touch. Every star in the sky is pulsing out a message from its hidden heart, a message written in warmth, a message written in time, and that message doesn't reach us unchanged. No, it is softened, filtered, altered by every layer it passes through. It's like hearing a drum through snow, or footsteps across a foggy field, muffled but still present. This is how we begin to understand stars, not by visiting them, but by measuring the tiniest flicker of their light. So the next time you see one, just one, twinkling above your roof, you might remember, the flicker you see is the echo of a heartbeat that began before pyramids, before writing, before any dream of science, and it is still beating, still glowing, still rising toward the surface, still shaping the silence of the sky. Let's drift deeper now, just a little deeper, into the hidden hush where hydrogen hums. The heart of the star has steadied. The first thumps of fusion now repeat, again and again, like the slow breath of something vast and dreaming. This is where the quiet music of starlight begins, not at the surface where we see it, but in the smallest of places, the nucleus of a hydrogen atom. Hydrogen is patient. It waited billions of years after the birth of the universe, floating freely through expanding space. Now, in this gathered core, it is finally close enough to touch its neighbours, and under the immense pressure, it becomes brave. It begins to fuse. 4 protons, like notes in a chord, are drawn together. 2 of them transform, becoming neutrons, and what results is a helium nucleus. But in the process, a little mass disappears. Not lost, transformed. Transformed into energy, into light, into motion, and the star pulses. Not from muscles or nerves, but from this ceaseless exchange. Hydrogen becomes helium, mass becomes energy, pressure becomes glow, the rhythm continues. But this is not a sharp rhythm, not like a ticking clock. It is softer, more like the swell and ebb of breath in sleep. Fusion doesn't happen in bursts, but in an eternal tide, rising and falling ever so slightly with each moment, each change in pressure or temperature. Now imagine yourself as one of these new photons, this energy born in the core. You blink into being not with vision, but with vibration, trembling with the heat of fusion's fire. And then you wait, because in the dense, crowded centre of the star, you cannot go far without being caught. An electron deflects you, an ion absorbs you and releases you again, over and over, 1,000,000 collisions, 1,000,000,000 wrong turns. It is the slowest journey imaginable. To travel a distance that light could cross in seconds through empty space, you will take thousands, perhaps millions, of years. This is the strange truth. The light we see from a star tonight may have begun its journey before humans painted caves, before we built fires, before we had names for the sky. You, as that photon, are shaped not just by the fusion that birthed you, but by every interaction along your journey. Like a word passed from mouth to mouth in a game of whispers, your energy changes slightly each time. By the time you reach the outer layers, you no longer carry just the heat of the core. You carry the story of the star's interior, the pressure, the density, the rhythms of the plasma ocean that surrounded you. And so the light that emerges, eventually gently, onto the surface of the star is shaped light. Light encoded with memory. Light bearing the pulse of hydrogen's sleep. Some stars sleep quietly, their light steady, soft, constant. Others twitch, others fluctuate, a little brighter, a little dimmer. They pulse, not in the fusion core itself, but because of waves, like musical overtones rippling through their layers. These are the variables, the stars that sing with brightness. Cepheids, Ara Lyrae, mirror variables. Each has a unique pattern. They expand, they contract. Their outer layers rise and fall like a chest in slumber. And because the light changes with each breath, we can measure that rhythm from light years away. We cannot see the fusion, but we see what it becomes. Imagine looking at a candle and knowing how warm the hand that lit it was. That is what it's like to study stars. And the glow, the visible flickering light we see from Earth, is not just the surface shining. It's a wave, a whisper that began deep inside, a whisper from hydrogen, dreaming in heat. So tonight, if the sky is clear, you might find one bright point and hold your gaze. Don't wish on it, just listen. That light may be hundreds of thousands of years old. It began as a pulse, a breath, a birth deep in the belly of a star. It has wandered, collided, changed, softened, but it kept going, and now it rests gently in your eye. It is still warm, still singing, still shaped by a heartbeat you can't hear, but you can feel. There is something strange and beautiful about how the inside of a star is built. It isn't empty, it isn't uniform, it isn't even solid. It is layered, dreamlike, complex, alive with motion. We have drifted from the core, that fusion-born cradle of light, into the next vast zone. It is quieter here, but not still. The energy we followed, that patient photon born in heat, has entered a new kind of dream. We're inside the radiative zone now. Picture it not as a place, but as a sensation, dense, dim, and eternal. Here, energy does not flow in clear waves. It zigzags, still caught in a labyrinth of matter. Each time it moves, it is scattered, absorbed, re-emitted. Its path is a tangle of confusion, but the motion never stops. The photons drift outward slowly, each one a pilgrim searching for light. The rhythm here is not one of breath, but of vibration, of particles exchanging heat in invisible dances, a dense, gentle transfer, no sound, just movement, and then, after thousands or millions of years, they reach a border. Beyond that edge, something changes. The particles are farther apart, the temperature is lower, and suddenly the rules shift. We're now in the convection zone. This place is different. Here, energy doesn't meander, it rises. Hot plasma surges upward like boiling water, carrying warmth with it. It swirls, it churns, it circulates in vast columns, hotter materials rising, cooler ones falling back down. Imagine standing inside a sun-sized tide pool, where the water is not wet but made of light and plasma, and it turns endlessly in loops as wide as continents. That is what this place feels like, and the heartbeat changes. Where the radiative zone was a slow whisper, this is a deeper pulse. The whole outer layer of the star is breathing now, bubbling and roiling with cycles of heat and motion. These convective currents are loud in their own way, not in sound but in effect. They stir magnetic fields, they build up tensions and flares, they twist and release energy like rubber bands snapping. And this agitation, this pulsing turbulence reaches the surface, and what we see, what we call starlight, is born. Not directly from the core, but from here, from the surface, shaped by all that came before. And yet even this surface isn't smooth. It flickers. It flickers because the convection bubbles are constantly rising and sinking. Imagine the surface of a pot of water just before it boils, little pockets forming and collapsing. That's the photosphere, the visible skin of the star. The rhythm is now tactile, visible. The star is glowing, yes, but it is also shimmering, trembling in microscopic waves that reach across space. Some of these tremors come from deep within. Others are born in this very layer, stirred by magnetic fields and twisted plasma. From the outside, we see only the light, but now we know this light is a message carved through many dreams. Core, radiative zone, convection shell, each one a layer in the lullaby, each one shaping the glow we see. In larger stars, these layers are even more complex. Some have multiple fusion zones, shells inside shells, each burning a different element, each with its own rhythm. A kind of celestial harmony forms, and each time the core changes, each time a new element fuses, the heartbeat shifts. Faster, slower, lopsided, rhythmic. Stars are not eternal, but during their long lives they evolve from within, and each internal change causes a ripple on the surface. We might never dive into those layers, but their presence is written in the light, and so we continue our journey, not outward, but upward, rising like one of those convective currents, drifting slowly toward the edge of the star. There's light waiting for us there, and when we reach it, we'll look back, not with our eyes, but with our thoughts, and remember the nested dreams that shape this glow, from deep fusion to turbulent churning, from rhythmless heat to patterned flicker. Each layer holds its part in the song. Each breath of the star comes from all of them. We rise now, gently, toward the edge of the star. Not the true edge, not yet, but the place where the light finally slips free. It's called the photosphere, though names feel heavy in a place so delicate. You might think of it instead as the star's skin, thin, luminous, trembling with invisible music. Here, the energy that began deep in the core has finished its journey. It no longer scatters helplessly, no longer collides with ions in a crowded interior. It rises and escapes. A photon steps out, and the universe changes. You hover here, just above the surface. Not in space exactly, but in that thin veil between inside and out. The light is constant, yet never still. It flickers, not wildly, not dramatically, but subtly, like candlelight in a slow wind. This is not noise, it is the final note of the star's heartbeat. For the pulse of a star is not a drumbeat, it is not a rhythm you can tap your finger to. It is slow, woven into brightness. And here, in the shimmering of the photosphere, we begin to truly see it. Imagine ripples across a lake, not water, but plasma, not wind, but waves of pressure, some born in fusion, others in magnetic knots below. These ripples rise and fall, subtly brightening and dimming the light. They are not chaos, they are signatures. To us they appear as tiny variations in brightness. A star may brighten by a fraction of a percent, then dim, then brighten again, regularly, predictably, gently. This is how the star speaks. Not in language, not in voice, but in rhythm, in glow. And astronomers, those quiet listeners of light, have learned to translate this flicker. It's called photometry, this careful measuring of light over time. They take long, slow looks. They gather data not over minutes, but over days, months, even years. From these measurements, patterns emerge. Some stars pulse every few hours, others every few days. Some have overlapping rhythms, multiple pulses, some shallow, some deep, weaving together like threads. It's tempting to say these patterns are songs, and in a way, they are. Because each flicker, each repeating change in light, reveals something hidden. The rate of pulsation tells us the star's size. The brightness it reaches tells us how far it must be. The shape of its flicker curve, the steepness of its rise, the smoothness of its fall tells us about the star's interior, its density, its temperature, its age. In a single cycle of light, a whole biography is written. And what's even more tender is this: the variations we see now might have started thousands of years ago. The photons reaching your eye tonight may have begun their journey before we had cities, before we looked up with purpose. Their flicker is old, but it still arrives. The light touches everything: leaves, roofs, lakes, your face. And though we no longer navigate by stars the way we once did, we're still held by them, still warmed, still guided. And the glow we see, however steady it appears, is not smooth. It breathes. The star breathes. Even our own sun, so seemingly constant, has its own subtle pulse. It brightens and dims across 11-year cycles. It trembles with waves of pressure, thousands of them, creating standing patterns that ripple across its face like the surface of a golden drum. These patterns are measured through helioseismology, the study of sound waves within the sun. Not heard, of course, but seen in light, mapped in motion. And in this way, we can listen to the star from within. We never touch it, but we always feel it. So let's stay here for a moment longer, hovering just above the surface, watching the light escape. It flows not like water, but like memory, slow, shaped, burdened with stories from the centre. Each flicker is a message, a wave, and somewhere, perhaps across the galaxy, another being might be looking at our star, seeing its light flicker gently and wondering, what shaped that glow? What beat inside? And like us, they might discover that the surface is not the beginning. It is the end of a journey that began long ago, with the soft heartbeat of a sleeping star. The light has left the surface now, but we stay just a little longer, hovering near the rim of something enormous and ancient. Our view shifts. The star we've known shrinks behind us, and ahead, another rises. It is larger, cooler, redder, a giant. We drift toward its surface and the temperature drops, not to cold, not even to warmth, but from millions of degrees to merely thousands. The colour deepens, gold becomes amber, amber becomes red, and the heartbeat slows. This star, a red giant, is nearing the end of its long life. It has swollen to an unimaginable size, its outer layers expanding into space like breath released after holding it for millennia. And still, it pulses, more visibly now, more deeply. The flicker is no longer faint, it is profound. The entire surface brightens, then dims, swells, then sinks. The light we see from afar is now undeniably shaped by the motion beneath. This star is breathing, truly breathing. Imagine standing near it. If you could survive the heat, the surface would rise toward you in slow motion, as if the whole star were inhaling. And then it would recede, falling gently back like a sigh. This is stellar pulsation made visible. Inside, the core is compacted and fusing helium now, more violent, more desperate. But the outer layers, spread thin and far, are free to move. They respond to pressure changes like a vast ocean tide. Up close, the edge of this giant doesn't look solid. It is soft, blurry, a glowing mist, and within that mist you can feel the rhythm. These stars are called mirror variables, named after one of the earliest discovered. Their changes are slow and majestic, weeks, even months between pulses. The brightness can rise tenfold, then fade again. Their heartbeat is drawn out, almost melancholy, yet it's peaceful. The whole star shivers gently, not like something breaking, but like something remembering how to move. Why does it pulse? The reason is simple, but beautiful. As the outer layers expand, they cool, and the light dims. Then, as gravity pulls them back inward, the gas compresses, heats up, and brightens again. It's a cycle, an elegant feedback loop driven by physics but felt as motion. Bright. Diamond soys bright. Diamond soys breathe in, breathe out. And because these pulsations are regular, almost clock-like, they become tools. Astronomers use them to measure distances across galaxies. Like candles that grow and shrink on a perfect schedule, these stars let us chart the cosmos by their steady glow. The red giant doesn't know this, of course. It simply pulses. Its core continues to burn, but one day it will run out of fuel. When it does, the heartbeat will falter. The outer layers will drift away into space, a planetary nebula, soft and glowing like a ghost of breath. But for now, it breathes, and we, listening from across the void, can feel that breath in every rise and fall of its light. Some stars tremble with youth, some flicker with fury. But the red giant shivers with memory. Its pulse is slower, sadder, softer, yet it shines. As we drift back from its surface, the rhythm remains with us. We carry it like a lullaby, steady and old, a reminder that not all brightness comes from fire. Some light comes from letting go, some glow comes from swelling into silence, and some heartbeats are meant to be seen. Now we drift alongside a star whose rhythm is starting to falter. It has grown older, older than any tree, any mountain, any planet with a name. Once steady, once patient, its light now stumbles. Not chaotically, not violently, but like a breath that pauses too long, a step that lingers mid-air, a song that forgets its next note. This is the breath of a dying star. Its pulse is no longer clean and gentle. Instead, it comes in uneven waves, surges and stutters. You wouldn't notice from Earth, not immediately. To our eyes, the star still shines, still flickers, still keeps time, but we know now how to listen. And in the flicker, we can feel it, the slowing, the stretching, the tired rhythm of a giant losing its core. Inside, the fuel is nearly gone. The fusion that once held back gravity has weakened. Layer by layer, the balance has shifted. The outer shell grows unstable, flaring and contracting. Sometimes the star expands so wide that its surface cools and darkens. Then it shrinks, heating and brightening again. The heartbeat becomes breathless, and that breath becomes visible. The star begins to shed. Outward, in slow bursts, it releases gas and dust, casting off pieces of itself like memories too heavy to hold. These flows drift into space, glowing faintly in the starlight, forming halos, veils, rings. It doesn't happen all at once. The process takes thousands of years. But with each breath expelled, the star becomes less of what it was, smaller inside, quieter, closer to stillness. Imagine watching it from the side, this old star pulsing in reddish gold, surrounded by the mist of its own fading. Its light flickers on a schedule that has begun to waver. The peaks and valleys of its brightness curve no longer line up precisely. They drift, they stretch. This is what it means for a star to grow tired. But there is beauty in the faltering, because these pulses, uneven as they are, do something wondrous. They shape the space around the star. The expanding gas is pushed outward by the rhythm itself, like music carrying dust on the air. These waves ripple into the surrounding cosmos, forming spheres and arcs and shells. Patterns emerge, and every pattern holds a memory of the heartbeat that made it. Some stars near the end release one final enormous pulse, a helium flash, an internal convulsion that burns bright and fast, then fades. Others settle into a series of increasingly faint shudders, like ripples fading on a once lively sea. And though the light weakens, the story becomes clearer. Because in this stage, we can read the pulse more easily. There are stars whose outer layers echo with acoustic waves, actual vibrations that bounce from core to surface and back again. These seismic tremors shape the star's brightness, creating harmonics we can detect from across galaxies. We don't hear them, but we can see them, ripples of brightness, frequencies etched into the light. It's called astroseismology, this quiet science of stellar sound. And as the star's strength fades, its vibrations grow longer, slower, deeper, like a song that's slowing down, like a lullaby nearly finished, and what remains, a shell of light, a memory, a glow. The heartbeat doesn't stop all at once. It fades gradually until what's left is barely a flicker. But that flicker carries meaning. Even in its weakness, it pulses. Even in its dying, it glows. Even in its final trembling rhythm, it shines. And to us, watching from far away, that light is not just a flicker in the dark. It is a farewell. And like all farewells from stars, it comes not in silence, but in pulse. Not all stars fade quietly. Some, in their twilight, begin to sing. You would not hear them, of course, not with ears, but their light speaks with startling clarity. These are the stars whose pulses become messages, steady and musical, across deep time. They are known as variable stars, and among them some stand apart for the precision of their rhythm. Their brightness rises and falls not like a fading ember, but like a metronome, reliable, exact, almost lyrical. They don't die in silence, they perform, and this performance is ancient. Long before telescopes, humans looked up and noticed that a few stars changed. Mira, the wonderful, would brighten and vanish on a schedule. Cepheus the king lent his name to stars that pulse like clocks. Even without instruments, these rhythms caught our attention, steady flickers in the dome of night. Now we understand them more deeply. These stars aren't flickering from clouds or shadow. They are truly pulsing, expanding and contracting in cycles that affect their brightness. Their surface moves, outward, inward, pushed by heat, by pressure, by echoes deep inside. They are stars whose whole bodies ring. The cause is simple and miraculous. Deep inside, energy builds, then it tries to escape. But the outer layers of the star resist. They absorb the heat, become more opaque, trapping light, like hands cupped around a flame. This causes pressure to build. The star expands. As it expands, it cools. The outer layers become more transparent. The light breaks free. Pressure drops. The star contracts, and then it begins again. This cycle, this breathing, creates a regular, measurable pattern, a pulse. Imagine watching such a star. Every few days or every few weeks, its glow intensifies, then fades, then returns. A heartbeat made visible across space, and these cycles are consistent. So consistent, in fact, that we can use them as tools. Cepheid variables, for instance, have a simple rule. The longer their cycle, the brighter they are. This law, discovered by listening to their pulses, allows astronomers to measure distances across galaxies. A Cepheid's glow is not just a flicker, it's a ruler, a map, a whispered song that says, "This is how far I am." Other stars, like RR Lyrae variables, pulse faster, but with the same reliable pattern. Their light curves are sharp, symmetrical, exact. They too serve as markers across the dark. These stars don't just shine, they calibrate the universe. Their heartbeats give a scale. And this is the quiet wonder. From a single rhythm in a single star, we can measure the size of galaxies. We can anchor our understanding of space itself. But the beauty runs deeper still. Because not all variable stars are neat. Some stutter. Some mix multiple rhythms at once. 2 or 3 cycles nested together like overlapping waves in a pool. These stars are rich with motion, layered with depth. Their flickers become complex music, a celestial chord rather than a single note. And each variation holds meaning. One star may pulse with surface waves, another may shiver with internal echoes, seismic pulses that rise from the core like tremors in sleep. Together, they give us a portrait of the star's structure, not just its outer glow, but its internal scaffolding, its density, its shape, its secret moods. It's a kind of cosmic ultrasound. We learn the hidden shape of light, and what makes this knowledge all the more luminous is that it comes from silence. No roaring engines, no probes, no travel. Just watching, just listening, just learning to read the light. So tonight, somewhere beyond the glass of your window, a variable star is pulsing. Its surface is rising and falling like a tide. Its brightness is telling a story in a language made of rhythm. And if you had the patience, you could sit and chart it, night after night, month after month, and watch as the heartbeat forms a pattern. Not random, not accidental, but chosen by the star itself. A story written in glow, a soul perhaps shaped in pulse. Let's go even quieter now. We've listened to stars whose pulses rise and fall with grace, whose glow sings steady, whose flickers repeat like a lullaby. But what if we could take that flicker and lay it out, like a scroll of light? What if the pulse became a line? Across vast observatories far from cities and their crowded skies, telescopes wait with still lenses, pointed at the same stars night after night. They are not waiting for fireworks, they are waiting for rhythm, and they receive it, not as a burst, not as a flash, but as a slow collection of numbers. Brightness, time, brightness again. Each observation adds a single dot to an invisible line. These lines are called light curves, and they are the soft music of the cosmos made visible. Imagine plotting each flicker of a star's light over days, a simple graph. Time on one side, brightness on the other. What emerges is not noise but shape. A rise, a dip, a repeating wave, a heartbeat drawn in silence. Each type of star makes a different shape. Cephids make smooth, asymmetric arcs, rising quickly, falling slowly. Ra Lyrae stars have tighter curves, sharp and quick, like the beat of a hummingbird. Mira variables build long, slow hills, weeks to rise, weeks to fall, and binary stars, pairs that eclipse each other, create sudden dips in brightness as one passes in front of the other. Their light curves look like heartbeats that skip, then resume. Each shape is a clue, a guide, a key. Even tiny variations, no more than a fraction of a percent, can speak volumes. A sharp point may reveal a magnetic flare. A wobble might hint at a planet tugging on its star. A doubling of rhythm may suggest another body nearby, whispering through gravity. We don't just see these patterns, we feel them. You can take a light curve and feed it into a synthesizer, translating brightness into sound. The result? A real, audible tone. Warped and winding, yes, but rich with character. It is, quite literally, the music of the stars. You're not imagining it. They do sing. But their songs are spread across time. Days for one note, weeks for a phrase. To listen is to wait. To hear is to remain still. There's a kind of faith in it. You watch the same point of light. You let time stretch. You trust that the star will speak again. And it does. The regularity of a variable star's light becomes its fingerprint. No two stars pulse exactly alike. Even those of the same class vary subtly, like voices sharing a melody but adding different breath. And these differences matter. Because when you know the rhythm, you can know the distance. When you know the shape, you can know the mass. When you know the flicker, you can know the age. It's as if, from a heartbeat alone, you could know the entire life of the creature behind it. And that is what we do. From these curves of light, scientists can build models, simulations of the star's interior, its temperature, its size. We never touch the star, never go near it, but we know it. As if from across a room, you watch someone breathing and learned their whole story. The light doesn't lie. It may flicker, it may hide, but it carries with it the truth of fusion, of motion, of pressure, of age. It carries the memory of 1,000,000 collisions and the imprint of 1,000 layers. And it always arrives. No matter how long it travels, it always reaches us. So somewhere tonight, a telescope is open. It is not hunting planets, not watching explosions. It is simply staring at a point of light, recording each flicker, turning it into a curve, and listening very patiently for the next breath of a distant sun. The sky grows darker as we drift farther. Not from light, but from what we can see. Because now we listen for pulses that the eye alone cannot follow. These are the rhythms beyond brightness, beyond red and gold, beyond visible light entirely. Some stars pulse in ultraviolet, others in X-ray. Still others whisper with neutrinos, ghost particles that slip through matter untouched. The deeper we listen, the more we realize starlight is only part of the song. Let's begin with the very fast. There are stars that change their brightness in seconds, tiny, twitching pulses so quick they seem like static in the silence of space. But they are not random, they are precise. Delta Scuti stars, for instance, vibrate rapidly, hundreds of times a day. Their surfaces ripple with acoustic waves flickering like the surface of a disturbed pond. Then there are white dwarfs, the remnants of long-dead stars. Cool, faint, and ancient, they still pulse, faintly, slowly, like echoes in a hollow shell. Their pulses are so weak they're often drowned in light, but in ultraviolet they become clear, crisp, like a single tone from a quiet bell. Other stars, hotter and more massive, emit their most intense rhythms in X-rays. These are stars that burn with violence. Magnetic fields twist and snap. Particles accelerate to near the speed of light. Their energy is too intense for eyes, but not for instruments in orbit. X-ray telescopes watch the sky not for light, but for bursts, flares, pulses, and even these, chaotic as they seem, have patterns. Every few minutes, every few hours, a flare, a dip, a rise. It's still a heartbeat, just harder to hear. And what of neutrinos? They are the faintest of messengers, born in the core of the star at the exact moment fusion occurs. They do not bounce or slow or scatter. They pass through the star like light through glass. They pass through planets, through us, through everything. And if you build a detector, deep underground, shielded from all other noise, you can catch them. Just a few. But enough to feel the rhythm of fusion in real time. This is the closest we've ever come to hearing a star's true voice. Not the surface, not the glow, but the core itself, its trembling, its pressure, its motion. And some stars don't flicker in brightness, but in position. They move, wobbling ever so slightly, because something is pulling on them. A planet, perhaps, or a dim companion. This too is a kind of pulse, a gravitational heartbeat. And when we measure these shifts, we discover the unseen, objects that do not shine but still shape the rhythm. Even black holes can be found this way, not by their glow, but by the way their gravity disturbs the pulse of a nearby star. Light bends, time stretches, the flicker warps, and we learn, again, that pulse is more than brightness. It is movement, structure, change. It is the way a star tells us, I am not alone. And sometimes the silence itself is part of the story, a missing pulse, a sudden dimming, a steady light that suddenly vanishes. These absences are not empty, they are transitions. Perhaps the star has collapsed, perhaps it has merged, perhaps it has shed its layers and become something else entirely. And so, to study the rhythms of stars is not just to admire their glow, it is to read their biographies, to sense their relationships, to follow their transformations. It is to understand that the universe has many ways of breathing. Some are visible, some are ultraviolet, some are shaped in neutrinos, some ripple in X-rays, some speak only through gravity. But all of them pulse, all of them change, all of them offer rhythm, and if we learn to listen across every spectrum, across every kind of silence, we find the heartbeat again. Even when there's no light, even when there's only shadow, the pulse remains. Now we begin to map the star's inner life, not by digging, not by drilling, but by tracing its pulse. The way a tree's rings reveal years of rain and drought, a star's rhythm reveals everything it hides. You don't see its layers with your eyes, you feel them in the light. You study the flicker, how fast, how deep, how bright. And in these measurements you find mass, you find radius, you find age. Each pulse is a messenger from deep within, the core where fusion burns, the radiative shell where light scrambles, the convective zone where heat surges like breath. Each of these layers leaves its fingerprint on the glow. The way the star pulses tells us not just what it's made of, but how it's structured. Like sonar in the deep ocean, like tapping on a wall and listening for hollows, we send no signal, yet we receive the shape. This is the wonder of astroseismology. It allows us to see without seeing, to touch without contact. We measure the oscillations of brightness. We model how waves move through different densities and compositions, and from these gentle pulses we reconstruct the star's anatomy. Where is the helium? Where is the convection? How quickly is the core burning? How close is the end? Even the age of a star is no longer just a guess. Its pulse reveals the years. Because as a star ages, its internal pressure changes, its density shifts. The frequencies of its tremors drift ever so slightly, like an old piano falling out of tune. And we can measure it. You might not imagine that such precision could come from light, but it does. A light curve, just one, can give us a complete cross-section of a distant sun. We see not only where the light comes from, but where it began. And this lets us go farther, not just to study stars, but to chart galaxies. Because when we understand the light of one kind of star, we can recognize it elsewhere. A Cepheid in another galaxy flickers with a familiar pattern. We know its pulse, we know its brightness, and from that, we know its distance. Each star becomes a landmark, a point on the cosmic map, a pulse marking location, and not just location, but time. Some stars are ancient, so old that their light began before Earth existed. Their pulses are slower, gentler, stretched by age and cooled by time. Others are new, bright and tight in rhythm, burning hot and fast. By collecting their pulses, we begin to write the history of a galaxy, where its oldest stars rest, where its youngest stars gather, where clusters expand like slow explosions. We can even chart the thickness of a galactic arm, the shape of a spiral, the warp of a halo, just by listening. And in this listening, we become cartographers of light, drawers of invisible maps, tracers of echo. What once looked like points of brightness on black now becomes terrain, movement, story. And the key to this story, the guidebook, the compass, is pulse. The rhythm of stars gives order to the distances between them, gives meaning to the light, gives context to the night. And as we stand here, stargazers tracing curves in notebooks and screens, we're doing more than observing. We're aligning ourselves with the heartbeat of something enormous, something older than breath, something quieter than wind, and still it pulses, still it glows, still it maps its own mystery one flicker at a time. Sometimes a single heartbeat is not alone. Sometimes two stars are bound together, dancing in gravity, pulsing in tandem, their light and rhythm tangled into something far more complex. We call them binaries, and in this quiet chapter, we drift gently toward one such pair. From a distance, they appear as one light, steady, singular. But if you look more closely and listen carefully to their pulse, you'll notice something strange. The brightness dips and then returns, again and again. A regular blink, like an eyelid gently closing. These are eclipsing binaries, two stars orbiting one another, passing in front of each other like shadows. When one blocks the other, the light we see dips. When they separate again, the light returns. It is not a random flicker, it is a clock. And with each dip, we learn more. The depth of the dimming tells us the size of the stars. The timing of the cycle reveals their orbital period. The sharpness of the change shows us the inclination of the orbit, how tilted it is in relation to us. Just from light, we can draw their path. And some binaries do more than block each other. They pull. They tug on each other's surfaces, stretching their shapes into teardrops. As they orbit, these stars exchange material, streams of gas arcing from one to the other like silk ribbons in slow motion. This exchange affects their pulses. One heartbeat may quicken, the other may slow. The stars are not just orbiting, they are evolving together. In extreme cases, they may even merge. And when they do, the final pulse is a burst of light, brief, bright, then fading, a flash of unity. But even before such endings, we can feel the shared rhythm in the light. Some binaries beat in complex harmonics. One star pulses at 1 rate, the other at a second, and together they create a pattern like interference on a still pond. These mixed beats are called beat frequencies, a rhythm born of 2 heartbeats crossing paths. In more distant systems, the gravitational pull may not be strong enough to cause eclipses or exchanges, but it still leaves a trace, a wobble. The star may pulse with its own internal rhythm, but if it moves slightly toward us and then away, the pulse appears to shift. We call this the Doppler effect, a red shift when the star moves away, a blue shift when it moves closer, and by measuring this shift we detect the companion, even if we never see it directly, even if it is dark, even if it is a black hole. The pulse tells the story, and these binary heartbeats, when traced over time, reveal stories of intimacy and transformation. Some stars are born together and remain forever entwined. Others come close, dance briefly, then drift apart. But in that time together, they shape each other's light, and their shared rhythm becomes something more than the sum of its parts. Tonight, as you lie still, consider that nearly half of all stars in the sky are part of such a pairing. What seems singular is often plural. What seems steady is often shared, and each flicker in the night may be not one voice, but 2, entwined, balanced, dancing, breathing, together. Now the rhythm breaks, not gently, not slowly, but all at once. The core collapses, and the heartbeat stops. This is not the end of light, but the end of its making. Fusion ceases, and gravity, unopposed, claims everything. We're no longer watching a steady pulse or a graceful flicker. We're witnessing a fall. The star has reached the limit of what it can carry. Too much iron in its core, too little fuel to push back. The layers that once breathed in slow rhythm now crash inward in silence. And what happens in that instant, barely a second, is one of the most powerful events in the universe, a supernova. From the outside we see an explosion, sudden, bright, expanding. But from the inside we see collapse, core into neutron, atom into ash, pressure into impossibility. The heartbeat doesn't fade, it is crushed, gone in a flash, but not without legacy. Because sometimes, at the centre of that collapse, something remains, a neutron star, and this remnant pulses again, but not like before, not slowly, not softly. It spins, it screams, it flashes. These are pulsars, neutron stars that rotate with extraordinary speed, beaming light from their poles like cosmic lighthouses. They do not glow steadily, they flicker with razor precision, 30 times a second, hundreds even. Each flash is a whisper from the void, a heartbeat, reborn. But now the rhythm is mechanical, a remnant of mass and magnetism, a relic of collapse, and it is exact. You could set a clock to a pulsar. Some are so precise that we use them as timekeepers for experiments across the galaxy. A dead star, spinning, flashing, pulsing, without breath, but with perfect regularity. Their light curves are sharp and sudden. No smooth hills, no drifting waves, just spikes, bursts, beats. And in this new kind of pulse, we glimpse the ghost of the one that came before, because these neutron stars still carry the memory of fusion, of collapse, of the pressure that once kept them whole. Their very density, so extreme that a teaspoon would weigh billions of tons, is proof of the collapse that silenced the original rhythm. And yet, something pulses, even in death. But the story goes deeper. Sometimes the collapse is even more complete. The core contracts past the neutron stage, past visibility, into shadow, into a black hole. And now, even the pulse disappears. No flicker, no flash, no light. But even here, the ghost remains. The surrounding material caught in the pull spins into an accretion disk, hot, bright, unstable. Its light varies wildly, flickering not from within but from orbiting chaos. And this too has pattern, quasi-periodic oscillations, unstable, irregular, but real. The signature of something massive, invisible, and final. And sometimes, gravitational waves ripple from these systems, waves in the fabric of space-time itself. A new kind of pulse, no light, just motion, felt across the cosmos like the vibration of a distant bell, and we can detect them. We can listen to the echo of a merger, of two neutron stars colliding, of two black holes spiraling into silence, a heartbeat in the shape of gravity. It is the most elemental rhythm of all. So even when a star dies, when its glow vanishes, when its body becomes shadow, the pulse continues, changed, twisted, amplified, or silenced, but never meaningless. Because the rhythm that collapses becomes the rhythm of something new. The glow that ends becomes the gravity that draws others in. And in this, the heartbeat lives on, not as light, but as memory. Even after death, some stars refuse to go silent. Their hearts no longer beat in fusion, yet their rhythm endures in echoes, small, persistent, strange. White dwarfs are among these quiet remnants. They are what remains when a low or medium-mass star like our Sun breathes out its final layers and leaves behind a dense glowing ember. No longer pulsing with life, no longer fusing elements, but still hot, still bright, still flickering. At first glance they seem still, but look closer. Some white dwarfs pulse, not from motion of the surface, not from expansion and contraction. Their pulses are interior, a slow seismic shiver, like a bell struck gently after a long silence. These are gravity mode oscillations, pressure waves drifting through a cooling crystal of stellar ash. Imagine standing on such a surface, the size of Earth, but hundreds of thousands of times denser. Your weight multiplied unimaginably. Above you, no flame, just faint, steady light. And every few minutes, every few hours, the star shudders, slightly, quietly, and the glow changes, barely, but enough to read. Astronomers monitor these changes, and through them they listen not to a heartbeat, but to a final breath echoing through solid matter. It's like hearing a whisper inside stone. These tremors reveal the inner structure of the white dwarf, its cooling layers, its crystallizing core, the presence of oxygen, of carbon, of heavy elements forged in the final moments before death. Even in quiet, the star still speaks, and some white dwarfs go farther. Some spin rapidly and flare with bursts of light, fed by material from a nearby companion. These are cataclysmic variables, systems where a white dwarf feeds on the leftovers of another star. The gas spirals in, forming a disk. It builds, it heats, and then, in a sudden flash, nova, not a supernova, just a surface detonation, a flare of brilliance, the pulse of hunger. This rhythm, quiet, then bright, is irregular, but it returns, again and again. A white dwarf feeding, flaring, resting, and repeating. Then, farther out in the graveyard of stars, we find pulsars, those fast-spinning neutron stars we visited before. Some of them pulse not just with light, but with radio waves. Each rotation sends a beam sweeping through space. We don't always see it, but when we do, it arrives like a lighthouse flash. Once, then again, with millisecond precision. They don't need to breathe, they don't need to shine, they spin, and that is enough. And the pulse, so precise, so steady, reveals their story, how fast they spin, how strong their magnetic field, whether a companion star is nearby, feeding them mass and momentum. Some are ancient, some newly formed, but all carry the ghost of collapse, all pulse with purpose, and sometimes the pulse stutters, slows, then speeds up again. These glitches are seismic shifts, quakes within the neutron crust, where immense pressure finally cracks the outer layer and the rotation adjusts. A star quake. Even dead stars can tremble, and even these tremors teach us. They reveal the composition of neutron matter. They let us peek into the behavior of material under pressures we cannot replicate. Each flicker, each pulse, each deviation, it is all information, encoded in rhythm, written in silence. These stars, once vibrant and breathing, are now hollowed echoes, yet their glow, dim, sporadic, but persistent, reminds us that even at the edge of stillness there is pattern, there is structure, there is time. So when we look up and see only the brightest stars, we must remember some of the most faithful pulses come from what we can barely see. White dwarfs cooling in the dark, pulsars flickering like clocks inside the bones of galaxies, dead stars still whispering, still moving, still counting, still shining. Let's pull back now, farther, farther still, until the stars blur together, not into a smear of light but into a choir. A galaxy is not silent. It hums, it glows, it pulses. Not as one star, but as millions, each flickering with its own heartbeat, its own tempo. Together they form something grander, something layered, a cosmic symphony with no conductor, no sheet music, only the shared rhythm of birth, life, death, and light. Imagine drifting above a spiral galaxy, arms curling like waves in slow motion. Each arm is dusted with star clusters, hot, young stars that pulse fast and bright. In the dense core, older stars pulse more slowly, cooler, wiser. Some have died already. Their remnants spin quietly in the dark. Others are being born right now within clouds of gas lit from within by embryonic suns. And all of them, every point of light, flickers. Everyone adds to the rhythm. We often think of galaxies as fixed, paintings in space, but they are alive with motion. Stars orbit their centers, clusters move like weather systems, gas clouds swirl and collapse, even entire arms flex over time, and the light changes. On long timelines, far beyond human years, the brightness of a galaxy pulses ever so slightly. Bursts of star formation create waves of illumination. Supernovae flare and fade. Black holes flicker in X-rays, consuming gas in surges. It's not chaotic, it's not random, it's breath, galactic breath. We've even begun to classify galaxies based on these variations. Some have bursts of variable stars clustered tightly, marking spiral arms, outlining the paths where stars are young and hot and unsteady. Others, in quieter elliptical shapes, pulse with the steadier glow of red giants and ancient variables. And then there are starburst galaxies, intensely active, pulsing with newborn stars, so bright that their combined heartbeats blend into a roar of ultraviolet light. And even among the millions of stars, some stand out. Lighthouses in the crowd, Cepheids and RR Lyrae variables, those stars with measurable, predictable rhythms, shine through the noise. Astronomers use them to measure distances, to trace the spiral arms, to build maps of the invisible. From a single flickering point, we can chart the shape of a galaxy. We can follow its structure. We can understand its age, its history, its motion, all from rhythm, all from glow, and then step back farther still, to the level of clusters of galaxies, superclusters, cosmic filaments stretching like threads between voids. Each galaxy pulses. Each galaxy is a rhythm in a greater rhythm. The universe itself breathes, faintly, across billions of light years. We see fluctuations in the cosmic microwave background, tiny differences in temperature that speak of ancient sound waves moving through the newborn universe, echoes of the first breath, the first ripple, the first pulse, and here we are inside that breath, inside that rhythm, measuring its echoes, tuning our telescopes not just to brightness, but to time, to pulse, to silence, to change. And through that listening, we come to know the shape of what we cannot see. We learn that galaxies are not fixed. They shimmer, they breathe, they flicker, slowly and forever, in the darkness. So tonight, when you gaze at that faint band across the sky, the Milky Way stretched above, you're not seeing a still picture. You're hearing a chorus. You're feeling the rhythm of millions of stars, some pulsing fast, some pulsing slow, all woven together into a light so wide it becomes silence, and in that silence the galaxy lives and glows. We have floated through luminous arms and brilliant clusters, but now we drift into deeper dark. Here, between galaxies, there is no music, only a silence so vast it feels like falling. Light thins, the stars grow sparse. This is the intergalactic void, a place where even the brightest rhythm seems far away. And yet, the pulse continues, fainter, but real. This is where astronomers turn their instruments to ghost notes, those faint, flickering signals that barely rise above background noise. The task here is not to watch a glowing star, but to find the whisper of a whisper. Because not all stars live in neat patterns. Some are wanderers, stripped from galaxies by collisions, drifting alone through emptiness. They shine without a host, no galactic arms, no companions, just darkness and their own quiet rhythm. These are intracluster stars, lonely but not lost. Their glow is faint and their pulses are subtle, but they're there. With sensitive telescopes, astronomers detect them not by their brightness, but by their change in brightness over time, the smallest variation, the faintest pulse, and sometimes, hidden in the void, a sudden flare appears, an echo from something long unseen, a supernova, or the death of a star swallowed by a black hole. Its light may arrive billions of years after the event, a final flicker from a ghost. Even quasars, supermassive black holes at the centers of distant galaxies, can pulse, though not like stars. Their rhythms come from the chaotic dance of matter in their grasp, accretion disks flickering with bursts, echoing with gravity. Some pulse every few days, others every few years. No heartbeat, but still, a pattern, a change, a rhythm written in chaos. These ghost notes help us reach farther, much farther, because the farther we look, the older the light becomes. Stars from the early universe flicker not in visible light, but in infrared, a long, low hum. Their pulses stretch with time, red-shifted by the expanding cosmos. And in that stretched rhythm we glimpse the past. We see how stars lived in the first galaxies, how they burned, how they died, how their heartbeats shape the structures that would become galaxies, clusters, the vast web of everything. Sometimes we find entire populations of variables scattered like dust across this deep field, flickering together, bound by nothing but the memory of light. And even beyond the light itself, we now chase pulses through space itself. Gravitational waves, the ripple of merging black holes, the final spiral of neutron stars colliding. These waves pass through everything, through galaxies, through stars, through Earth, through you. They arrive as distortions, not seen, not felt, but measured in the tiniest changes of distance. They are a new kind of pulse, born in places where even light cannot escape, and yet they reach us. And when we listen with the right tools, LIGO, Virgo, other detectors poised like ears against the fabric of space, we hear them. Like the deep toll of a bell rung in another universe. Even in this dark, the rhythm persists. Even here, where there are no stars to see, the cosmos remembers how to breathe. The ghost notes are real, and they are part of the same song. The stars pulse, the galaxies shimmer, the void hums, and we listen. Even in silence, let us come home now, out of the dark, through the spiraling arms of distant galaxies, past the variable stars and pulsars and drifting ghost notes, back to our star, the one we know as the sun. It sits quietly in the sky, bright, familiar, and seemingly unchanging. Day after day it rises, it warms, it shines, but it too has a pulse. We simply don't notice, because we are held inside it. The sun's rhythm is slow and soft. It does not flicker wildly. Its heartbeat is a whisper over decades, but it is there, and it shapes everything. At its heart, like every other star, hydrogen fuses into helium, releasing energy that flows outward in a long, tangled climb through its layers. The core pulses with pressure and light, but so steadily that we rarely think of it as rhythm. Yet the rhythm reaches us. In 11-year cycles, the sun grows more active. Sunspots appear, solar flares erupt, magnetic fields twist and snap. Then it quiets again. This is the solar cycle, a heartbeat of magnetic breath. And with each pulse, we feel its effect. The solar wind strengthens, pushing out through the solar system, shaping the heliosphere that shields Earth from cosmic radiation. Auroras dance in Earth's sky. Satellites feel its warmth. Tides and seasons adjust to its rhythm. Even life on Earth evolved beneath its subtle changes, its warmth rising and falling across millennia, guiding migration, growth, hibernation, bloom. And more intimately, the sun's constancy regulates our sleep, our wakefulness, our days. Its light, filtered through cloud or sky, sets the tempo of human biology. Circadian rhythms, breathing, heartbeat, a rhythm within a rhythm. We live inside the pulse, and we've learned to study it too. Heliosysmology listens to the sun's internal waves, pressure ripples that bounce around its core and outer layers. These standing waves create subtle surface tremors, tiny vibrations in the sun's photosphere. With sensitive instruments, we can watch them, map them, listen. And through them, we glimpse the sun's inner structure, its temperature, its rotation, its density. Just like with distant stars, we trace the hidden with surface rhythm. Even nearby, the sun remains a mystery made knowable through pulse, and it will not last forever. In billions of years, the hydrogen will dwindle, the core will contract, the outer layers will swell, the sun will become a red giant, just like the ones we drifted through earlier in this journey. Its rhythm will change, its glow will deepen, its pulse will slow, and eventually it will cast off its outer layers. Its core will remain, a white dwarf, glowing in the dark, Even then, long after our world is gone, it will pulse, gently, softly, in silence. But for now, the sun is steady. Its heartbeat continues. Its light arrives on time. Its glow sustains oceans, trees, animals, us. And when we close our eyes beneath its warmth, we're not only comforted by its constancy, we are perhaps remembering its pulse. And now, the final breath. Not of one star, but of all of them. Every heartbeat ends. Every rhythm slows. Every light, no matter how bright, must one day fade. But nothing is truly gone. Not in the universe. Even when the fusion stops, when the last breath leaves a dying core, something remains. A shell of glow. A memory of rhythm. The final light. We drift now among those remains. White dwarfs, slowly cooling for trillions of years, still faintly glowing, still pulsing with occasional tremors in their crystallizing hearts. Neutron stars spinning with eerie precision, each rotation a clock that marks the death of a giant and the birth of time. Black holes, invisible but powerful, curving space and bending light. No glow of their own, but ringed by fire if something draws too close. The graveyard of stars is not a place of silence, it is a field of echoes. Each remnant hums with the past. Each one tells us what came before, and what's more, they give back. The material shed in death, those layers cast off in final trembling pulses, becomes the soil for new stars. The carbon in your breath, the calcium in your bones, the iron in your blood, all born in stars whose pulses ended long before the earth was made. Every end glows into beginning, and stars are not selfish in death. They scatter their light across time, their elements into clouds, their rhythm into memory. New stars form from these ashes, new rhythms begin. A newborn star gathers mass, compresses, ignites. The heartbeat starts again, and the universe keeps breathing. This is the great rhythm, the true pulse of everything. Not just the rise and fall of light, but the cycle, the return, creation from collapse, light from silence, glow from gravity. You could say that a star's heartbeat shapes its glow, but you could also say that the glow, gentle, flickering, eternal, shapes us. Our night sky is built from pulses that began before our ancestors walked upright. The light in your eyes tonight may have begun its journey when the earth was young. It travelled across the vacuum, across centuries, carrying the memory of a fusion breath, a layered rhythm, a fading glow, and now it rests in you. So when you look up, remember, every flicker is a life, every variation is a heartbeat, every glow is a whisper that once said, I was here, I burned, I breathed, I became, and in the quiet between the stars new pulses wait, ready to begin, ready to shape their glow, and now we let the rhythm fall away. The pulses that carried us through fire and silence, through flickers and flares, through death and becoming, have grown faint, like footsteps retreating across snow. You are still. The stars are quiet now. Each breath you take feels slower, softer, as if the very space around you has grown wider. The sky above, whether cloudy or clear, is no longer a ceiling, but a field where light once wandered, shaped by time, shaped by breath. The glow that shaped galaxies now simply lingers. There's no need to search it, no need to follow, only rest. You've drifted with the photons, felt the thrum of fusion in the deepest core, heard the quake in a white dwarf's silent sleep. You've watched the flicker of two stars locked in orbit. You've stood beside our own sun and felt its gentle, ancient breath. And now, the rhythm pauses. You're floating, held in gravity's cradle, carried on light older than memory. The universe exhales, and you do too. Let go of thoughts, let go of shape, Let go of brightness. Just drift, like a star that has finished burning, a soft ember in a soft sky. No questions now, only quiet, only warmth, only the slow familiar rhythm of rest.